Why is this remote and rugged river in Alaska turning orange? New research suggests the Salmon River is full of toxic metals that are likely harming fish and other aquatic creatures. Alaska's Salmon River was once so clean that author John McPhee described it as the clearest, purest water I have ever seen flowing over rocks. Now, however, the remote waterway is a muddy, orangish-yellow mess. It's brimming with toxic metals, at concentrations that are likely harmful to aquatic life. The culprit? Thawing permafrost resulting from climate change, according to a study published in the journal Proceedings of the National Academy of Sciences last month. It's a sobering study, says Diane McKnight, a geochemist at the University of Colorado Boulder who was not involved with the research, to Chemical and Engineering News' Fiona Samuels. The Salmon River winds 70 miles through Kobuk Valley National Park in northwest Alaska, flowing from Mount Angayukiksrak to the Kobuk River. The federal government designated it a National Wild and Scenic River in 1980, noting its large salmon runs and its water of exceptional clarity. However, around 2019, the once crystal-clear waters of the Salmon River and its tributaries turned orange and murky. Patrick Sullivan, an ecologist at the University of Alaska Anchorage, and Roman Dial, a now-retired biologist at Alaska Pacific University, first noticed the unusual hue during an unrelated research trip in the region. The Salmon River had become what's known as a rusting river, a phenomenon caused by the presence of high amounts of iron and other metals. Sullivan, Dial and their colleagues returned to the waterway to take samples in 2022 and 2023. Based on their analyses, they suspect it has fallen victim to sulfide mineral weathering, also known as acid rock drainage, which can occur when permafrost thaws. Found primarily in the Arctic and some high-elevation regions, permafrost is the name given to soil, sand, sediment and rock that remains at or below freezing temperatures for at least 2 years. The bedrock beneath some permafrost contains sulfide minerals, which are typically inaccessible to groundwater. However, when permafrost thaws, those minerals become exposed to water and oxygen for the first time in hundreds or even thousands of years. As the minerals dissolve, they produce acids, which in turn cause metals to leach out of rocks. In this way, acid rock drainage is a form of natural pollution that can occur far from humans, even though it's caused by human activity. There are few places left on Earth as untouched as these rivers, says co-author Tim Lyons, a geochemist at the University of California Riverside, to BBC Wildlife magazine's Daniel Graham. But even here, far from cities and highways, the fingerprint of global warming is unmistakable. No place is spared. The team's analyses show the Salmon River is chock full of metals, including aluminum, cadmium, copper, iron, nickel, and zinc, at concentrations above the U.S. Environmental Protection Agency's safe limits for aquatic life. If there were a mine that were operating in the headwaters of the Salmon, they would be facing regulatory intervention at this point, Sullivan tells Chemical and Engineering News. Pollution from mines is typically limited to a single source and can be managed with treatment systems. Acid rock drainage caused by permafrost thaw, on the other hand, is occurring at various sites and is nearly impossible to mitigate, the researchers say. The only hope for solving this problem is the recovery of the permafrost, which of course would involve pretty massive emissions reductions at this point, Sullivan tells Chemical and Engineering News. And the ripple effects of permafrost thaw are not limited to the Salmon River. The process can occur in any waterway located near permafrost covering sulfide-rich bedrock, and scientists are using satellite imagery to look for other rivers and streams that might be affected. The high levels of toxic metals in the Salmon River might help explain a recent drop in the number of chum salmon returning to spawn, the researchers say. But, they add, they need to conduct more research to confirm that hunch. Even if the pollution is not to blame for the depressed salmon runs, it's likely still affecting the local food chain. It would be very hard, for instance, for a bear to fish for a salmon just because of the turbidity, Sullivan tells the Alaska Beacon's Jareth Rosen. Raptors would have a really hard time catching a fish if they were fishing there. The water is simply too cloudy, he says, citing his own failed attempts to fish the river. The metals also seem to be harming aquatic insects, such as stoneflies and mayflies, a source of food for many fish, per Science's Warren Cornwall. In parts of the Salmon River with high levels of aluminum and iron, for instance, the scientists found very few insect larvae. We have no idea when that process might reach its conclusion and how many new acid seeps might develop, Sullivan tells the Alaska Beacon.